Hello learner, I am teacher LIDWINA, your guide in exploring on this lesson. So this class was designed and written with you in mind. Primarily, it aims to be able to define terms and concepts in algebra and translate verbal phrases to algebraic expressions and vice versa. While going through this lesson, you are expected to define constants, variables, and algebraic expressions. Identify exponent, base, and power. Identify the literal and numerical coefficient from a polynomial. Identify the degree of a term and of the polynomial and translate verbal phrases to algebraic expressions and vice versa. Every day in our lives, we deal with relationships between objects and any other things. We also use symbols to express ideas and messages.
While going through this lesson, you are expected to 1. Define constant variables and algebraic expressions. 2. Identify exponent, base, and power. 3. Identify the literal and numerical coefficients of a term. 4. Differentiate an algebraic expression from a polynomial. 5. Identify the degree of a term and of the polynomial. And 6. Translate verbal phrases to algebraic expressions and vice
Every day
versa.
in our lives, we deal with relationships between objects
Every
and
day in our
any other
lives, we deal with
things. We use
relationships
also
between objects
symbols
and
to
any other
express
things. We
ideas
also
and
use symbols to express
messages.
ideas and messages.
Here are some examples of signs and symbols. What do these signs and symbols mean? Find the meaning of these symbols from column A to column B. The same in mathematics, wherein in this lesson you will be able or dealing with patterns and express them as relationships using constants and variables. You will also use symbols in translating verbal phrases to algebraic expressions and vice versa. To do this, you must be familiar with the words, phrases related to the different operational symbols. Thank you, learners. I hope you learned something from this lesson. Thank you for listening and answer the given activities in your class and check your answer based on the answer key at the back of your class. See you on the
For
next
lesson 1,
video.
we are dealing with constants, variables, algebraic expressions, and polynomials. Before we will discuss the following, we will define first the following terms. So a constant is any symbol representing one fixed value. Examples: 4, -6, 1/2, pi, and so on. While variable is any symbol representing possible values of a quantity. Examples: a, b, x, y, and x sub 1. So a variable is any symbol or letter representing any number, and it is written after the constant. An algebraic expression is a constant, a variable, or a combination of constants and variables involving mathematical operation on them. Examples of algebraic expressions are 8a, 4a, 8xy, 3x minus 5, and 2y. So these examples indicate multiplication, like for A, the constant is always placed before a variable. So the constant there is 4. For example, 8xy, the variable x and y are placed side by side alphabetically, and it is written after the constant. In an indicated product, the factors or the product of the factors are called coefficients of the rest of the expression. If the factor is constant, it is called a numerical coefficient. If it is a variable, it is called a literal coefficient. Let's take here an examples. Now, example number 1, AB, meaning the product of 1, A and B. The numerical coefficient is 1. If no constant is written, the numerical coefficient is understood to be 1. And the literal coefficient are A, B. For example number 2, y divided by 5, also written as y over 5. It is more natural to write an 5 indicated quotient as fractions. So the numerical coefficient is 1/5. The literal coefficient is y. A numerical expression is a combination of numbers, grouping, symbols, and arithmetic operations. So examples, 10 plus 4 minus 5, or 5 plus 2 times 4 to the third power, and 8 plus square root of 36 minus 4. An algebraic expression consists of terms which are separated by plus or minus signs. A term is a constant or constants a variable, and an indicated product or quotient of expressions containing variables and or constants. Examples: A. N. The term n is a variable. Letter B. 3 pi. The term is a product of two constants, 3 and pi. And letter C. Close and open parentheses or quantity x plus y. This expression consists of one term because of the grouping symbol quantity. And letter D, 3x squared minus 5y, the expression has two terms listed as 3x squared and negative 5y. And for letter E, it has only one term. The negative sign before the product is considered part of the term. Always remember that the sign preceding the term is a part of the term, like in example D. Furthermore, grouping symbols can affect the number of terms of an expression, like in example C. Two or more terms with the same literal coefficients are called like terms or similar terms. They are unlike terms or dissimilar terms if they have different literal coefficients. Examples: 5ab and negative 7ab are like terms since they have the same literal coefficient ab. 6xyz, negative 2xyz, and negative 8xyz are like terms since they have the same literal coefficient x, y, z. And 12a and 16ab are unlike terms since the literal coefficients a and ab are different. And x cubed, y squared, and x cubed y are unlike terms because the variables have different exponents. A polynomial is an algebraic expression where each term is a constant, a variable, or a product of constants and variables, where any variable must have whole number powers. Examples: 4, 3x plus 2, negative 2x cubed, square root of 3, a squared, b squared, a squared minus 3a plus 6, a plus b plus c. Take note that the polynomial 4 can actually be written as 4x raised to 0 since x raised to 0 is equal to 1. An algebraic expression is not a polynomial when the variable is in the denominator. Let's take 3 over a, or the exponent of the variable is not a whole number. Let's take a raised to 1/2 or 2y raised to negative 3. And the variable is under a radical sign like square root of m. Polynomials are classified according to the number of terms in the given expression. Polynomial, these are the kinds of polynomial: monomial, binomial, trinomial, four-term polynomial, or quadrinomial. So example of monomial is negative 5x cubed. Terms of the polynomial: negative 5x cubed. Number of terms 1. For binomial, example of binomial: 3x plus 2. Terms of the polynomial: 3x and 2. Number of terms 2. Because 3x and 2 was separated by plus sign. And then trinomial, example, a squared minus 3a plus 6. Terms of the polynomials are a squared, negative 3a, and positive 6. The number of terms are 3. And four-term polynomial or quadrinomial, example, 3 cubed s raised to 4 minus r raised to 3 plus rs plus 2. So what are the terms? R cubed s raised to 4, negative r s cubed, rs, and 2. So now the number of terms are 4. You can actually name a polynomial according to the number of its. The degree of monomial or degree of a term is the exponent of its variable or the sum of the powers of each variable in the term. Examples: monomial. So 6. The degree is 0. The exponent of the variable is 0 since 6 can be written as 6x raised to 0. Number 2 example, negative 4a. The degree of monomial is 1. The exponent of the variable a is understood to be 1. 3m squared, the degree of monomial is 2. The exponent of the variable m is 2. And last example, 5x squared y cubed, degree of a monomial 5. Get the sum of the exponent of the variable x, which is 2, and the exponent of the variable y, which is 3. Hence, 2 plus 3 equals 5. The degree of a polynomial with one variable is the value of the largest exponent of the variable that appears in any term. Example, in polynomial 2m cubed minus 4m squared, the degree is 3. The largest exponent of the variable m is 3. And example number 2, 6n cubed plus n raised to 5 minus 2n. The degree of exponent is 5. The largest exponent of the variable n is 5. Example number 3, 6m squared 9 minus 5n mn cubed. degree of exponent. 4. The highest degree among the terms in the polynomial 6m squared n is 3, negative 5n cubed is 4. Example number 5, 12x squared yz squared plus 6x squared yz minus 8xyz. The degree of exponent is 5. The highest degree among the terms in the polynomial 12x squared yz squared is 5. 6x squared yz is 4 and negative 8xyz is 3. A polynomial is in standard form if the terms are arranged from the term with the highest degree to the term with the lowest degree. The terms are arranged in the descending order of powers. So examples: polynomial number 1, y squared minus y plus y4 plus y3. So remember, it is not arranged. So we have to arrange this one in descending order. So the descending order, or we call this as the standard form of polynomial, is y4 plus y3 plus y squared minus y. And example number 2, negative 4m cubed n squared minus 2m4 n squared plus 7mn squared. So we have to arrange the exponent: negative 2m 4 n squared minus 4m raised to 3 n squared plus 7mn squared. When a polynomial is written in standard form, the first term is called the leading term, and the numerical coefficient of the leading term is called the leading coefficient. So example here, y raised to 4 plus y raised to 3 plus y raised to 2 minus y raised to 1. The leading term here is y raised to 4, since the highest exponent is 4, and the leading coefficient is 1, since the numerical coefficient of y raised to 4 is 1. And another example, negative 2m raised to 4 n raised to 2 minus 4m raised to 3 n raised to 2 plus 7mn raised to 2. The leading term here is negative 2m raised to 4 and n raised to 2, because if you will add them, 4 plus 2, the exponent 4 plus 2 is 6. And then the leading coefficient is the numerical coefficient of the leading term, negative 2. Polynomials are also classified according to the greatest degree of the polynomial in one variable. So these are the kinds of polynomial and its example. So 1. Linear. Example, 2x plus 4. The degree is 1 since the largest exponent of the variable x is 1. Second, quadratic. Example, x squared minus 2x plus 1. The degree is 2, meaning the largest exponent of the variable x is 2. And the third one is cubic. Example is 2a cubed minus 4a. The degree is 3, and the largest exponent of the variable a is 3. Next is quartic. Example, 3y raised to 4 plus 2y raised to cube minus 4. The degree 4. The largest exponent of the variable y is 4. And next, quintic. Example, negative x raised to 5 plus 4x. The degree is 5, since the largest exponent of the variable x is 5. In lesson 2, we will discuss translating verbal phrases to algebraic expressions and vice versa. The table illustrates possible translations of words or phrases that are used to indicate mathematical operations. So we let n be the unknown, although any letter can be used as a variable. So I hope that you will discuss or you will read the following symbols and the word phrases, the meaning of the symbols, and then their meaning, the verbal phrases, and then the algebraic expressions. So these are words that indicate a change in order from the original verbal phrase. So the word done in verbal phrases, 2 less than 3 times a number, the algebraic expression 3n minus 2. Reason, this indicates that 2 will be written after the term 3n. And then from, the word from is 12 subtracted from a number. That is an example of verbal phrase. And in algebraic expression, we can translate that as n minus 12 for the reason that this indicates that 12 will be written after the variable n. Okay, so let's have more examples on translating the following verbal phrases to algebraic expression. So example number 1, the sum of twice a number and 6. If n represent a number, then twice a number means 2n. The sum of twice a number and 6 means 2n plus 6. For example number 2, 3 times the difference of a number and 4. If r represent a number, then the difference of a number and 4 means r minus 4. 3 times the difference of a number and 4 means 3 times r minus 4. Example 3. 5 less than 4 times a number n, meaning 4 times a number n means 4n. And 5 less than 4 times a number means 4n minus 5. Remember that the phrase less than reverses the order of the phrase you will translate. Example 4. The sum of a number m and 4 divided by 5. If m represent the number, then the sum of a number m and 4 means m plus 4. The sum of a number m and 4 divided by 5 means m plus 4 over 5. But remember, the placement of comma will help you decide how to properly group the term in an expression.
Thank you, learners. I hope you learned something from this lesson. Thank you for listening and answer the given activities in your last and check your answer based on the answer key at the back of your last. See you on the next video.